Hi, my name is Martin, and I'd like to welcome everyone to today's session where you can learn more about gaining confidence in your database changes. I'm a senior principal product manager, and I've joined Oracle in December last year. Hello and welcome to this session of Oracle CloudWorld, where I've got 30 minutes to inspire confidence in your database changes. And I'm going to try this in two different ways. First of all, I would like to introduce DevOps principles to you as an introduction to the topic. Before I'm going to cover technologies and how you can implement those DevOps principles that I just talked about in your daily deployment cycles. I'm going to talk about Liquibase and support in SQL. And once we've covered this, I would like to take it a step further and talk about process automation. Okay, so the table of contents for this presentation, we've got 30 minutes to talk about DevOps topics in general. Before I'm going to focus on Liquibase support in SQL, and I'm going to introduce the various mechanics on how you use Liquibase for deployments, and I'm going to run you through a little example as well. Furthermore, we'd like to talk about process automation, how you can use what you just saw in the previous slides in a fully automated way to deploy application changes into a cloud environment. At the end of it, I'm going to show you a video of how this can be done before I'm leading to a summary where I'm discussing the concepts for everyone to remember key concepts of this talk. So first of all, let's start off with a quick introduction. And I'm calling this a favor or the favor of automated, mostly hands-off deployment of all code. So what we think is that DevOps, which is a combined word combining development and operations, and we believe that these should improve the way that your teams both deploy and also code and integrate software changes into your life cycles. First of all, there are two things to talk about. The very first one is continuous integration. When we talk about DevOps, we usually talk about continuous integration / continuous delivery or deployment. And continuous integration basically means building and testing the latest changes and committing those to your code repository. Continuous delivery, on the other hand, allows you to then deploy these changes into an environment so that you gain confidence that your changes that you have just previously created are actually working. DevOps is very much a culture, an approach on how you deploy code in your production systems or even your test systems and QA systems and any other system for that matter. And what I have seen over the past years is that people have different degrees of confidence in new technologies and new approaches on deploying software. So what I would like to say before diving deeply into the topic, I would like to say that as a team manager, please also take into consideration your team's experience. If you've got a team that is using CI/CD principles throughout in other disciplines, writing Java code or other languages, then it's very likely that you can move quite quickly on your implementation of a DevOps culture. Otherwise, if your team is new to the technique, it's probably advisable to pick the low-hanging fruit, taking it step by step, and also making sure that everyone in the team is comfortable with the new approach to deploying code. And as I said before, DevOps is not a product, it's a change, potentially a change in culture. And although DevOps practices can be very useful in many ways, it is super important to engage everyone who has got to work towards these principles. And one thing that's almost certainly going to end in problems is pushing down a DevOps culture from the top without taking the team with you. So what I'd like to say is that a gentle approach is oftentimes more beneficial than doing this on a big bang. Okay, having briefly talked about DevOps and how it can be done and how it, principles and how you could adapt this, let's start with an example. And I would like to use Liquibase as a prime example for deploying code. And we've got support for Liquibase in a command line tool called SQL. So for those of you not familiar yet with Liquibase, it is a database independent library and open source tool for tracking, managing, and applying database schema changes. And the wonderful thing, I believe, is that there is significant ease of use by using SQL with built-in Liquibase support, because it allows you to create the necessary files based on either database objects or entire schemas. There is support for Oracle RESTful services in it, in SQL, and it also has support for Application Express. In order to understand deployments being done by Liquibase, there are 3 key topics to understand. The first one is the topic of the change log, and the change log contains changes to be made to the database. They can be quite simple, can be just one, or it could be a change log including many other change logs containing changes to be made. It all depends on your project, and it all depends on your release. Change logs are comprised of change sets, and these are the individual changes that you perform against the database, such as adding a column or creating a table, creating an index. And the change set also comprises the change type, which indicates the actual change nature, as I said. I firmly believe that SQL and its support for Liquibase is a key enabler in continuous integration and deployment, and I'm going to show you why I think so. First of all, if you use SQL and Liquibase together, you have consistency in your code deployments, because you have now standardized your deployment format onto one, and rather than having various different ways of deploying code, that could be tarballs with SQL scripts and a driver script. It could be just one major big SQL script that you run, or a combination thereof. With the use of SQL and Liquibase, you have one consistent way. So once your developers have mastered the way of Liquibase and SQL, they can apply this throughout. And changes are always deployed in each environment in an identical fashion. And the second thing that is also very important is repeatability, because Liquibase ensures that code changes are idempotent. So you're not going to risk running changes once more and then running into problems by doing so. And I'm going to show you in the demo later on why that is. And furthermore, there is accountability, which is very important, because Liquibase keeps track of what changes it has applied and when, and you can even see what individual changes have been made against the database by querying metadata tables it creates as part of a deployment. And as consistency and standardization both go hand in hand, because now you have a single format for all your database changes that can be used moving forward. Okay, so let's go into the practical part. Enough of the theory. See what you can do with Liquibase and source code management. So before you can use Liquibase, I mean, it's not a prerequisite, obviously, but it would be very useful and beneficial if you included all your changes that you intend to apply to databases and put them into version control systems. And version control systems are entirely essentially essential tools for the development process. And if you look online and at various programming languages and their tutorials, you find that most start off with a introduction to Git. So you start off with an empty project and then you work your way up from there. But it's all with version control systems. Interestingly, if you look at tutorials on the internet when it comes to SQL and PL/SQL, this isn't always the case. And then I would like to encourage you to think about using version control systems for your database changes, just as you do for your changes in other languages. Because the version control system provides a complete history of all changes. You can always go back to a good known state, which is very easy. You can go back through a history. You can find out what happened to a file over its lifetime. You can enable multiple developers to work jointly on a project. And while this is not frictionless, there are tools there that allow you to resolve conflicts and have those also documented on your way forwards to deployment. It's also much harder to override someone's changes if you use a version control system. I have recalled numerous occasions where multiple people have worked on a system and both have worked on the same, say, PL/SQL procedure, and the one who hits the compile button last is the one whose changes will prevail, whereas the changes of the first person get overwritten by those of the second person. So this isn't always desirable because it makes it very hard to track down problems. And there are a lot more good reasons for using version control systems, and far too many to mention them separately. So after this slide, I would really like to encourage you to consider Git, which is the de facto industry standard version control system for your SQL and PL/SQL development projects. It may be a little daunting at first if you haven't used them before, because it's a new tool chain to be learned, but there is a huge community out there. There is lots of documentation tutorials, both written in blogs and in videos that you can access. So those should not be too hard to get you into using Git for those things. And it doesn't have to be difficult, and I'm hoping I can show you that it doesn't have to be difficult on the next slides. So let's assume that we're starting off with a new application project, and as most applications these days, we require a database backend and to store some data from our front-end application. Let's assume now, to keep it simple, that this application just requires a table called EMP and a sequence to populate its primary key. And everyone who has been using Oracle will probably relate to those tables. I have just borrowed them here for this example. The example isn't supposed to show you a completely complex database backend application. The example is here to serve how to use Git and Liquibase together to embrace some more modern development techniques. So let's say we don't have an environment where we can create them, but thankfully it's now possible to use Oracle XE21C in a container database. And let's assume that our developer named developer1 starts one of those databases and creates the schema objects in his schema. Just to reiterate the point that Oracle XE is a very good option for this kind of projects when they start off low. So in this video, I have downloaded Oracle XE21C on my local machine, and I'm using Oracle Linux 8.6, and I'm using a container engine called Podman to start the container so I can start with my development project. All you need to do is create some setup, all of which is documented on the internet, which you can look at. Essentially, it creates a volume for persistently storing my data, and it creates a few passwords and a network as well. And now it's going to start my container. And just to show you that this takes not a lot of time at all, this is the very first time that this container starts. It initializes the database when it does so. It recognizes it hasn't got anything on this persistent storage. And as you can see, the listener has already been started. And in little to no time, the database will report that it is ready. So you can see it's already starting there. And after less than a minute, it is ready to use. So there you go. Now we can become productive a lot sooner. Okay, now that I've got a database, I need to create my schema objects, the ones as I have shown you on the previous slides. And once that's done, I've got a schema that is now ready for my first tests. And in order to do so, I would like to subject those files to version control. And that is actually a lot simpler than you might have thought at first. We're using Liquibase, like I said, and in Liquibase, changes are in a specific format. We call them change logs, like I explained a few slides before. And the way it's being done is that change logs list other change logs so that you've got like a driver change log, so to say, and those include other change logs in order to apply all these changes against the database. And you can automatically generate those. And since this is a fresh project, I can just ask Liquibase to create the change logs for the entire schema, which is quite simple. There is a command lb gen schema. So I'm connected against the database. After all my work is done, I can run lb gen schema -split. And since this is SQL CL, it understands the command and exports all the objects. And you can see on the right-hand side which objects it exports and how long it takes. So at the end of this, since I've got a table and a sequence, there are two files that Liquibase has generated, one for the sequence and one for the table, as you can see in the output on the right-hand side. And you can also see a controller file. This is the master changelog it creates. And I like to call it master changelog. And you can see that there are two include files commands there, where it actually includes the files in the right order for it to create the schema objects I've just created manually. Okay, so this is excellent because these files are text files, and every text file kind of naturally lends itself for inclusion in version control systems. Binary files are always tricky, but text files are wonderful for this purpose. One thing I would like to add real quick is the changelogs, as you can see, they are in XML format. So anyone who is not familiar in parsing XML on the fly, you can also supply a -SQL option to the lbgen schema command, and it will create a SQL file alongside. So you would find a SQL file with the actual SQL command to create the sequence and the table if you had specified those. But since they aren't used when it comes to actually implementing the change, I did not opt to create them here. Okay, so now I've got the files. What I need next is a Git repository, and it's actually quite simple to create one and add the files. And as you can see down here, it's in the gray box. All I need to do is I need to git initialize my repository using git add dot. I add all the files that haven't already been added to the repository. And then I can, just as a database, I can commit those files to the repository, and I need to give it, I need to provide a useful commit message. And these are very, very important, as we'll see later. So by convention, when you initialize an empty repository, it's you find lots of people say, this is my initial commit. And you can see down there, it adds the controller, the sequence file, and the table. And then I can query the Git repository for its status, and it says I'm on branch main, so I'm kind of in a working tree, and I've got nothing else to do. So very good. Once that's done, most developers opt on using a centrally hosted Git repository to allow collaboration workflows and such. So let's assume there is a central code repository which allows developers to work jointly on this project, and developer 1 has pushed his repository, his local copy of the repository, all the way upstream. Now he asks developer 2, can you please have a look at what I've done, see if this is kind of what we agreed we would do. Now, developer 2 connects to a database. In my case, it's the same database. It's a different user, but it could be a different database. It doesn't matter. The important bit is that you see it's using SQL CL to do so. And he connects then, or she connects then to the database. And the command the developer runs next after cloning the repository to a local directory is to run lb update. And you point it to the changelog, which is controller.xml. And it will, Liquibase will then analyze the files, and it says, oh, I found 2 change sets, one for the table, one for the sequence, and it runs them in the right order. And the important bit here is that you see no errors encountered at the end of it. Okay, now SQL CL and Liquibase both have been enabling us to run code written by other people, and it's exactly the same code in the same format, and it's been created in a different schema. So now developer 2 can continue working on it. But as we know, development never stops. New requests come in all the time in the real world, the same as in this demo. And I would like to continue with the demo showing that additional requirements have come in. We need to create another table, a few more constraints, and so on and so forth. So getting back to developer 1, he creates a new branch in the code repository, connects against the database, creates the new objects in the schema he has previously or she has previously exported. And this is what you can see here on the right-hand side. Once this is all done and there are no errors and it's ready to be exported, the developer runs lbgen schema again. And So same screen as before. Liquibase goes to work, sees what has changed and needs exporting. Well, actually, in this case, it exports everything into XML files. And looking at the files that are generated, you can find indexes and a procedure and another table. So still in the feature branch that has been just created, the developer adds the files and commits them. And here the commit message is implemented feature 001. And this is just an arbitrary name. It could be anything on your on your sprint, on your iteration, on your workflow board, whatever. Anything that makes sense to you is good. So now we're a step forward. And again, the code is pushed upstream to the centrally hosted Git repository. And developer 2 is interested in the changes, pulls them from this branch, and runs LB updates again, just as the developer did before to make those available. So connecting to the same system, you can query the status. And as you can see down here, 4 change sets have not been applied. Is what it says. There are 5 total. Previously, it was just 2. So you can see 4 have not been applied. Okay, so I kind of get a view of what's going to happen next. If I then run the LB update, the command to apply the changes, you can see on the output that it creates the table depth and it creates the other things just as it should have been doing. And again, a very important point is that no errors have been encountered. And when I said previously, there's a standardization, and there is the repeatability, and all the other good features. I haven't pointed out the accountability aspect. And as you can see here is there are tables Liquibase creates when it deploys things, and these they're called database changelog tables, and you can query them to see what has been done and when. So in my case, you can see all the change sets that have been executed against this database. Right. So now that there is an established process that can be followed, wouldn't it be nice if this process could be automated as well? And I sat down and used OCI DevOps service to automate the code deployments to an Oracle database. And the way it looks is this. I've got a developer on my left-hand side. The developer commits code against the OCI code repository, which triggers a build pipeline. And this build pipeline makes use of the OCI Vault. And it creates an autonomous database shared and provisions application code. And I've got a little application that connects to it to see if it all worked. And this application runs into in a small Kubernetes cluster. So the OCI DevOps service, just a very quick overview of how it works is you have developers. Developers have access to an OCI code repository, which can link to the other Git repositories that are publicly available. You can establish a link between those, but the principle is the same. You've got your local repository. You push upstream to the OCI code repository, and you can trigger build pipelines. And if necessary, those pipelines create artifacts, put them into the container registry or artifact registry, and then later on deploy them using a deployment pipeline. And they can be deployed against bare metal and VMs and Kubernetes and functions. But in my case, that's not really what I needed. I wanted to have something that clones a gold image copy of my database, which is sort of my sort of like production copy, so that I know how long it would take to run database changes. And I'm using Liquibase to run my changes just like I did before against this database. Now, there is the concept of the build pipeline, is where you define the runner, the system which is going to create those artifacts, or in my case, runs the Terraform code to spin up an autonomous database. And very important here is you link a repository, and then you say which file contains the various steps that need to be executed as part of this build pipeline. And in my case, and well, in OCI DevOps and in many others, you use a file written in YAML, which is a very important markup language for people to know. because it's also used in Ansible, say, and Kubernetes and elsewhere. So knowing YAML doesn't hurt. If you haven't seen it before, it's well worth learning. And in here, I just say, this runs in Bash. I've got a number of environment variables. They're kind of plain standard environment variables, but I also have vault variables that are, vault secrets that are stored elsewhere secretly and securely, so that I don't need to supply any passwords and usernames in this particular script, because that's a very, very, very bad thing to do. Storing any sensitive information in version controllers is a very, very bad thing to do. And just to show you how it works, the build pipeline starts off. It creates a build runner, and it clones the Git repository that you indicated in your build pipeline's definition, uses the YAML file to begin its work. And then it executes the steps serially. You also have failure handlers. If something goes wrong, you can roll back. And that's important in the cloud, not to leave any resources running that you essentially don't use. And imagine if lots of people did that, you could end up with a lot of costs. So it's important to think about what happens if a step goes wrong. And so there are lots of pre-installed tools. For Java, there is Maven and Gradle, there is Python, there is Terraform, and many more. And in here, I'm primarily using Terraform to create a copy of a ADB shared environment, and I'm connecting to that ADB shared environment to deploy my code changes. And at the end of the build pipeline, you can see the history of those, and they should all be green and have succeeded. And to show you how that looks like, here is a short demo triggering a run of a build pipeline. So this is the same build pipeline for which I showed the screenshots. Just to share that this is the one. I can then start a manual run in the OCI DevOps interface. And then you're greeted with the execution of the build pipeline. And the beauty of this video that I recorded is that we don't need to wait 5 minutes for it all to finish. It'll complete a lot faster. So you see the initialization phase now. It's getting the build runner, it's provisioning it, and it's later on downloading the code repository, and it performs the various steps as defined in the YAML file. And after 4:55, it has cloned the database, and it has deployed my application changes. And everything has been done successfully. As you can see, it's all green. You can see very detailed logging of the output. And when I later on, when I connect to the autonomous database that I have created, you can see it's up there. I log into database actions using my application user that I have just created, and I provide the password. I can then click on the Liquibase tab, and it shows me the various deployments that it has completed. So this is one way on how you could do a completely automated deployment of changes against an autonomous database shared. Okay, so we're coming up to 30 minutes. I've timed it reasonably well. Let's go to the summary screen. So first of all, deploying application changes automatically is a real game changer. Implementing continuous integration and deployment requires buy-in from all stakeholders, and the speed of adoption should be chosen carefully. On the other hand, once you've got this right, it is a wonderful position to be in. SQL provides support for Liquibase. As I said, it's substantially enhancing the developer experience, and also it makes your DBA's life a lot easier. There is a single format for all changes. There is accountability of actions and auditing of deployments. And deployment pipelines or build pipelines, depending on your project, can automate code rollouts. And it's built on top of the foundation Liquibase offers. And the builds can be triggered manually, as you just saw, or it can be done automatically as well. And with that, I would like to thank you for watching this video. I hope it has encouraged you to look into versioning your code and automating deployment a little more. This is one way to do it. There is, as with everything in IT, there are many more ways to do the same thing, but the concept should remain the same. And with that, I thank you and wish you a very great cloud world.